Welcome. This is Odum Maths. Today I want us to look at using the inverse of a matrix to solve the system of equations. So how do we use the inverse of a matrix to solve the system of equations? Now I want us to start from the 2 by 2, then later we'll proceed to the 3 by 3. Okay. Given this matrix, let's assume we have matrix A that is multiplying another matrix X, and the answer will be another matrix B. Okay, now before then, let me write A, or let's A be equal to, as usual, A, B, C, and then D. And then our matrix X will also be X, Y. Then our matrix B will also become, let me put, let's say W, Z. So then it means that our A times X equals B will become A, B, C, D, and then multiplied by X, Y, which is that of X, and this is equal to another matrix, W, Z. Okay, so now let's see how we are going to go about inverse method to solve system of equations. Okay, we are to make X the subject. Okay, so from this we can A times X equals B. We can divide through by A. So A here, and then our X becomes B over A. Okay. Now we can also rewrite. This in the form X equals A inverse then times B. So it means that when you find the inverse of A and multiply to B, we'll get the matrix X. So let's see an example. If 2x minus 5y equals 15, and then 3x minus 6y equals 36, we have to solve for x and y using the inverse method. We first need to write the coefficients matrix. So we let matrix A equals 2, neg 5, 3, neg 6. Then again we let x equals the variables x, y, and then b becomes 15, 36. Okay, so let's see how we can solve this with the inverse method. So we need the inverse of A first. So A inverse becomes 1 over the determinant of A times, then we interchange. So this is going to be negative 6 to negative 3, 5. Okay, so now let's find the determinant of A. So the determinant of A becomes 2 times negative 6, which is negative 12, then minus 3 times negative 15, which is negative 15, so that is plus 15. Okay, so negative 12 plus 15 becomes 3. Okay, now A inverse will give us 1 over the determinant, which is 3, so 1 over 3 times this one, negative 6, 5, negative 3, 2. Please, I've already negated and exchanged the positions. Okay, so now let's multiply. So 1 over 3 will give us 1 over 3 times negative 6 will give us negative 2. Then 1 over 3 times 5 becomes 5 over 3. Then 1 over 3 times negative 3 becomes negative 1. Then 1 over 3 times 2 becomes 2 over 3. Okay, so this is the inverse of A. So we need to multiply this to the b, so A inverse times b will give us x. Okay, so now our matrix A inverse times b is going to give us x. So A inverse, we had -2, -1 here, and then 5/3, 2/3. So that is going to multiply the b, and b is 1536. So let's see whether we get our x. So 2 times -2 times 15 will be -30 plus 5/3 times 36. So plus 5/3 times 36. It's like 5/3 times 36, and then 3 can divide this 12 times. 5 times 12 is 60, so that is 60. And then 1 times -1 times 15 is -15 plus 2/3 times 36. So 3 into 36 is 12 times 2 is 24. Okay, so the answer to this, is -30 plus 60 is 30, and then -15 times 24 is 9. So therefore x is the top component, so that is 30, and y is 9. Okay, let's look at one more example. Okay, now let's look at these two equations, how we can solve using the inverse approach. So we need to first write the coefficient matrix, or after we write the variable, then that of the constants. So we let A as usual be equal to the matrix 5, -3, so -3, then -2, 4. Okay, now we need the inverse of A. So we first need to find the determinant of A first. So per this, determinant of A becomes, that is, this and this is 5 times 4 is 20, plus minus -2 times -3 becomes +6. So 20 minus 6 is 14. Okay, now our A inverse will be equal to 1 over the determinant, which is 14, times, then we interchange, so 4, 5, then we negate this one, 2, and then 3. So we need to multiply. Now 1 over 14 times 4 is like 14 over 4, which is 2 over 7. So 2 over 7, and then 1 over 14 times 3 becomes 3 over 14, and then 1 over 14 times 2 becomes 1 over 7, and then 5 times 1 over 14 becomes 5 over 14. Okay, so this is the inverse of the matrix A. Okay, now we need to get A, the inverse of A times the matrix B. So our matrix B, we are going to let it be. Okay, and that of matrix B will also be 28, 14. Okay. Our A inverse times the matrix B should be equal to X. Our A inverse has been found to be 2 over 7, 3 over 14, then 1 over 7, 5 over 14, and that is going to multiply B, and B is 28, 14. So let's see. Now 2 over 7 times 28 will be 7 into 28 is 4, times 2 becomes 8, then plus 3 over 14 times 14, so that is 14 to 14 is 1, times 3 is 3. Then 1 over 7 times 28 will be 7 into 28 is 4, times 1 is 4, plus 5 over 14 times 14 is 14 into 14 is 1 times 5 is 5. So when we add these two, we'll get 11, and then this one also give us 9. So therefore our x is equal to 11 and y is equal to 9. Okay, let's solve one more example, then we draw curtains on this. Now let's solve this by the inverse method. So we need, I said we need a matrix, the coefficient matrix. Then after writing them, we find the inverse of the first one, the 2 by 2, then after. So we let A be equal to 2 neg 3, so 2 neg 3, 5, 7, 5, 7. And again, let's x be equal to x, y. And then our b also negative 4, 1. Okay, so don't forget that our A inverse times B should give us x. Now, our A inverse, we need the determinant of A. So the determinant of A becomes 2 times 7 is 14, minus 5 times negative 3, 15, so plus 15, and that is 29. Then again, A inverse is equal to 1 over 29, that is 1 over determinant, times, then I am going to interchange the positions of 7 and 2, so 7 will come here, 2 will come here, and then I will negate 5 and then negative 3, so negative 5, and then this place becomes positive 3. Okay, so I am going to multiply. Now, 1 over 29 times 7 will be 7 over 29. 3 times 1 over 29 becomes 3 over 29. And then 1 over 29 times negative 5 becomes negative 5 over 29. And then 2 becomes 2 over 29. So this is the inverse of the matrix A. Now we need to multiply this with B, so A inverse times B should give us x. So A inverse is 7 over 29, 3 over 29, then negative 5 over 29, and again 2 over 29. So this is going to multiply the matrix B, which is negative 14, 1. So negative 4, negative 4, 1. Okay, so we are multiplying 7 over 29 times negative 4. So 7 over 29 times negative 4 is, that is 20, negative 28 over 29. So negative 28 over 29. Then plus 3 over 29 times 1. So 3 over 29 times 1 is the same thing. That is 3 over 29 times 1 is 3 over 29. Then negative 5 over 29 times 4 becomes negative positive 20. So 20 over 29 plus 2 over 29 times 1, which is 2 over 29. Okay. Negative 28 over 29 plus 3 over 29. The denominators are the same, so we just need to add the numerators. So negative 28 plus 3 is just like negative 25. So x is equal to negative, so let me put it first in its order. So negative 25, 9, sorry, over 29. Then 20 over 29 plus 2 over 29. So the denominators are the same. So we add the numerators. So that is also going to be 22 over 29. So therefore x is negative 25 over 29. And then y is also 22 over 29. Okay. So we'll meet in the next lesson. Please don't forget to subscribe, like, and share this channel. Bye.